Okay, in this session, we will discuss Fourier series of even and odd functions. So first, I will define what is even function. So you already know that a function f of x is said to be even if f of minus x, instead of x, if I substitute minus x, it will be f of x itself. Such functions are called even function. For example, if you take f of x is equal to cos x, then f of minus x equal to cos of minus x. What is cos of minus x? Cos of cos, right? This is equal to f of x. So here f of minus x is equal to f of x. So this is even. I will give another example. If you take f of x is equal to x square, then what is f of minus x? Minus x all square. Minus x all square is x square, which is equal to f of x. So this is also even. Similarly, f of mod x, f of minus x is minus mod x, which is equal to mod x f of x. So such functions are called even function. So if it satisfies this condition, then the function is called even function. Now, then similarly, what will be odd function? A function f of x is said to be odd function. Tell me what is the condition? F of minus x equal to when we say that a function is odd function,
minus f of x.
minus f of x. Then we say that the function is odd function. For example, f of x equal to sin x. Then if we take f of minus x, this is sin of minus x. What is sin of minus x? Sin of minus x.
Minus sin x.
Okay, minus sin x. So this is equal to minus f of x. Therefore, f of minus x is equal to minus f of x. This is odd function, right? So if you take f of x equal to x itself, then f of minus x is equal to minus x, which is equal to minus f of x. This is odd function. Similarly, any odd degree number x cube, this is odd function, etc. So such functions are called odd function. Now I will define what will happen if product of even and odd function. So let f of x and g of x be uh, f of x and g of x be two functions. Okay, two functions. If f of x is odd and g of x is odd, then what you can tell about f of x into g of x? Is it an odd or even function? Anybody? F of x odd and g of x odd. Then what is f of x into g of x?
Even function. Even function.
It's even function. Okay. For example, if you take an example, f of x is equal to x, g of x is equal to again sin x, then f of x into g of x is x sin x. So if you put value f g of minus x is equal to minus x sin minus x, which is equal to uh, x sin x. So this is a even function. Similarly, if f of x is even and g of x is even, then what you can tell about f of x into g of x? Is it even or odd?
Even.
Even function. Even function. And what about third? If f of x is odd, odd and g of x is even. That means either one of them is odd and other one is even, then what you can tell about f of x into g of x? Is it
Odd function.
odd function? So that's very important. So if you have f of x and g of x two function, odd into odd, you will get even function. Even into even, you will get even function. Odd into even, you will get odd function. Similarly, even into odd, you will get odd function. Now there is a important thing is if integral of even and odd function in the interval minus L to L. That means suppose suppose f of x is even. Suppose f of x is even function, then integral minus L to L f of x dx is equal to integral minus L to L f of x dx is equal to, what you can tell about this?
2 into integral 0 to L f of x dx.
0 to L f of x dx. So this is very important. Now if f of x is a odd function, then what will be integral minus L to L f of x dx? 0. So this is very important because we will use while doing problems. Now I will give a Lebanese rule of integration. You already know the product rule of integration of okay. So let u and v be two functions, then Lebanese rule of integration is integral u v dx. U and v are two functions of x, then integral u v dx is equal to u v1. Okay, so what is v1? V1 is actually integral of v minus u dash v2, where v2 is actually integral of v1, which is equal to double integral of v, plus u double dash v3. Then what will be v3? Integral of v2, and so on, minus u triple dash of v4 plus etc. So this is useful when we are doing problems like so this rule is called a Lebanese rule or product rule of integration. So u into v is equal to u into v1. V1 is integral of v minus u dash v2, integral of v2 is integral of v1, and so on. Okay. So this is useful for finding integrals like x raised to n some function of v. Then after n plus 1th derivative of u is and and, and v is this. Then after n plus 1th derivative, this term becomes 0, right? After that term, all becomes 0. So for example, if you want to find x square sin x dx integral, then this formula is useful because uh, this is u and this is v. Then you can write u x square into integral v, that is v1. Integral v is minus cos x minus u dash. U dash is 2x into v2. V2 is integral v1. This is v1, right? Integral v1 is minus sin x plus u double dash. This is u dash. So 2 into integral minus sin x. This is cos. So minus u triple dash is 0. Then all terms become 0. So this is the integral. So this is useful if we have functions of this type, x raised to n into some function. Okay. Any doubt? So Lebanese rule is important. You should note down that rule. Now we will define what is Fourier series of even function. So let f of x be a be a be an even function defined on the interval. So this interval is very important, minus L to L. If it is not minus L to L, we cannot use that integral formula. Then, 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 then we know that what is A naught. Tell me what is the formula for A naught.
1 by L
1 by L integral
integral
minus
C to
L
C.
to L. Here integral is, interval is minus L to L, right? C is minus L and C plus 2L is L. So the interval is minus L to L, f of x.
F of x dot.
Here. So which implies A naught is equal to, the function is even. So what you can write? 2 by
By pi
L. L. Because
L L
L integral 0 to
0
L
to L.
f of x. Textbookly, I think they are using pi particular formula. I am using L because L is in general form. If L equal to pi, you can use that form. So this is A naught. What will be An? 1 by formula. Tell me the formula.
1 by L integral minus L to plus L f of
Minus L
x
to L f of x cos
cos
Nx
n by
n pi x by L. Because I am using L. Okay. Our interval is minus L to L and our period is 2L, not 2 pi. This is a general case. Dx. So what is f of x is even, and we know that cos n pi x by L is even, right? Both are even. Even into even function,
even
even function. So what you can write? This is 2 pi L integral minus 0 to L f of x cos n pi x by L dx. So this is the formula for A. Then what about Bn? Bn, formula for Bn, 1 by
1 by L integral 1
minus
plus L
L
f
to
of x
f of x sin n
sin n
pi
by x
by L dx. So what is this is even and sin n pi x by L is odd. Then what you can tell about this whole function f of x into c?
mod
This is odd function and we are integrating from minus L to L. Then what is Bn? 0, right? So Bn is 0. So that means if f of x is even function, we will get a naught an, but Bn is equal to 0. Therefore, f of x is equal to, what is its Fourier series? A naught by 2,
a naught by
2 plus sigma
plus
n equal to 1
n
to
equal to 1 to infinity
an cos n pi x by L. And Bn is 0. So that means this series only contains cosine terms. There is no sine terms. So this series is called Fourier cosine series because only cosine series is there. That means function is even, then we will get a Fourier cosine series. Similarly, what will be Fourier sine series, odd function? Okay, I will write what is A naught 1 by L integral. So now my function f of x is odd and defined on the interval minus L to L. Then what will be integral? This integral A naught. Tell me what is A naught? A naught is equal to, what is the
C
formula? Our interval is minus L to L. So C is here L minus L and C plus 2L is L and period is 2L. Okay. So minus L to L. So if you want to integrate A naught, we will take this endpoints of the interval as the limit. Okay. F of x here. So what if f of x is odd, then what you can tell about A naught? A naught odd ആണെങ്കിൽ what will be this integral? Minus L to L
0.
0. So what about an? An is 1 by L integral minus L to L f of x cos n pi x by L dx. So this function is odd and this is even. Then what you can tell about the whole function? Odd into even?
0.
Even. Oh, odd. Therefore this integral is 0. So we will get an is equal to 0. So for an odd function, a naught is equal to 0 and an is equal to 0. Then what will be bn? 1 by L integral minus L to L f of x sin n pi x by L dx, which is equal to, this is odd and this also odd. Odd into odd,
even.
even. So what you can write, 2 by L integral minus 0 to L f of x sin n pi x by L dx. So therefore Fourier series is f of x is equal to, a naught is 0, right? A naught is 0 and a n is 0. So we will get sigma n equal to 1 to infinity bn sin n pi x by L. So if function is odd, then in the Fourier series there is only sine terms. So this is called Fourier sine series. Okay, have you got it? Any doubt? Any doubt? Anybody have any doubt? Then
No, sir.
one more important thing is the convergence of Fourier series. So here, so in order to find values, so this is very important theorem. You should understand. So now I will define what is convergence theorem. So listen carefully. If f of x is a periodic function with a period 2L defined on interval c to c plus 2L satisfying Dirichlet condition, then the Fourier series of f of x is given by, what is Fourier series of f of x? We know that a naught by 2 plus sigma n equal to 1 to infinity a n cos n pi x by L plus bn sin n pi x by L. Have you got it? 1 by 2 a naught plus, this is Fourier series, right? then this Fourier series, if f of x is a point of continuity, or if uh, if x is a point of continuity, or x in between c and c plus 2l, that means x is in between. We have defined f of x on the interval c plus 2l. Then if x is in between c and c plus 2l, then this series is actually, this value is actually is equal to f of x, that point. Now if it is in the end point, that means at x equal to c or x equal to c plus 2l, then actually this series converges to the left hand and average of left hand and right hand limit, that is equal to 1 by 2 times f of c plus f of c plus 2l, c plus 2l minus. That means if we have a function defined minus pi to pi like this, if we want to find the value at this endpoint x equal to pi at the endpoint, then actually our Fourier series converges to f of 1 by 2 times f of pi plus, or f of pi minus plus f of minus pi plus. That is the convergence theorem. While doing the problem, you will understand that. That means x is a point in between c and c plus 2l, you will take f of x, and the point in between, that means end point x equal to c or x equal to 2 c plus 2l, then we will use the average of left hand and right hand limit. So we will do a problem, then you will understand how we will. So write down this problem. Find Fourier series expansion of the function of period 2 pi f of x equal to x square defined on the interval minus pi to pi. Then hence find the sum of the series 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus 6. Actually, what is this series? This series is actually n equal to 1 to infinity minus 1 power n plus 1 divided by n square. So in uh, in the last module
Alternating series.
we showed that this is alternating series, and we can prove that this converges. But I told you that it's very difficult to find the sum of the series. Okay, there is no method to find the sum of the series in uh, last module, right? We can either we can tell it is either convergent or divergent, but by using by application of Fourier series, we can find the sum of this series. Okay, so for that we will use convergence theorem. So listen carefully. One of the main application of Fourier series is you can find the sum of infinite series. So first of all, I will take what is f of x. F of x is given as f of x equal to x square, and it's on the interval minus pi to pi. So what is the interval? Minus pi to pi. So we have L equal to pi, right? This is like minus L to L. So L equal to pi. And tell me what is f of x? F of x is x square. Is it a even function?
Yes, sir.
Even function. So we know that if f of x is even function, then what you can tell about Vn is equal to 0, right?
0.
Now what is a naught? A naught is 2 by L. L is here pi. integral 0 to pi f of x dx. So 2 by pi integral 0 to pi f of x is x square dx. If we integrate this 2 by pi, x square integral is x cube by 3 0 to pi. If I apply limit, you will get a 2 by pi square, 2 pi square by. So we got a naught is equal to 2 pi square by 3. Now we will find an. An is equal to 2 by L. L is pi. Integral 0 to pi f of x cos n pi x by L. But L is already pi, therefore cos n pi x by pi. That is cos nx, right? We have an is equal to 2 by L. Integral 0 to pi f of x cos n pi x by L. This is the general formula, and we will apply. We have L equal to pi, integral 0 to 2 pi, 2 by pi 0 to pi f of x cos n pi by pi. So you will get cos n. So that is cos n. 2 by pi integral 0 to pi x square cos nx dx. So now here we will use Lebanese rule. Lebanese rule. What is Lebanese rule? This is x square is u and cos nx is v. So I already defined what is Lebanese rule. 2 by pi, first u is x square into v1. v1 is integral of cos nx. What is integral of cos nx?
Sin nx by n.
Sin nx by n. That is u. Here we get u v1 minus, so I will write the integral uv dx is equal to u v1 minus u dash v2 plus u double dash v3 etc. minus u dash this is equal to 2x integral of derivative of x square is 2x into integral of integral of sin nx by n, that is minus cos nx by n square, plus derivative of 2x, that is equal to 2 into integral of cos nx by n square, which is equal to minus sin nx by n cube 0 to 1. Now I am applying a limit. If you apply limit, you will get 2 by pi. If I put a pi square sin nx by n pi by pi plus minus and minus. Here there is minus sign and this minus plus 2 pi cos n pi by n square minus sin 2 sin n pi by n cube. Okay. Now if you apply the lower limit 0, this term becomes 0, this becomes 0 and 0. So lower limit is 0. So we know that what is sin n pi?
0.
0. So this term becomes 0, right? What is here also sin n pi is 0. Now what is cos n pi?
Minus 1 raised
Minus
to n.
1 all this one.
All raised to n, which is equal to 4 into minus 1 all raised to n, which is equal to 4. So what is f of x? Our Fourier series is of the form a naught by 2 plus sigma n equal to 1 to infinity a n cos nx, right? N pi x by L. That means L is pi, therefore cos n. Therefore, we can write f of x is here x square. X square is equal to 2 pi square by 6. A naught is 2 pi square by 3. Therefore, a naught by 2 is 2 pi square by 6 plus sigma n equal to 1 to infinity 4 minus 1 raised to n divided by n square cos nx. Okay. Now, if we expand this, you will get x square pi square by 3 minus 4 times. You can take 4 outside. When n equal to 1, you will get uh, if I take minus 4 outside, then cos x divided by 1 square minus n equal to 2 cos 2x divided by 2 square, n equal to 3 cos 3x divided by 3 square, etc. So I want to deduce the formula 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square, etc. So what for if I put ഏത് വാല്യൂ കൊടുക്കുമ്പോഴാണ് അത് കിട്ടുക? Anybody have any idea? If we put
Cos
x
0
0,
is
x
1.
equal to 0.
then what you will get this cos 0 is 1. And what is the point? X equal to 0 is a point in between the endpoint. It's not an endpoint, right? Here what is endpoint? One minute. Here what is endpoint? Endpoints are minus pi and pi, right? Minus pi and pi. But 0 is in between minus pi and pi. Therefore, it is not an endpoint. Therefore, what we can write here? If it is not an endpoint, then f of 0. You can directly write f of 0 is equal to, I can put the values. So, f of 0 എന്താണ്? 0 square 0 f of x is x square, right? So f of 0 is 0 square. Then I will put the value here, pi square by 3 minus 4 into 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc. Okay, have you got any doubt? That means x is a point in between my two endpoints. Okay, so we can directly write f of 0 is the point of continuity. 0 is, so which implies you can take it pi square by 3 is equal to 4 times 1 1 by 1 square minus 1 by 2 square plus etc. So which implies pi square by 12 is equal to 1 minus 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc. So what is the sum of this series? This is actually pi square by 10. So this is an important application of Fourier. Now, you do this problem. I want to deduce 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus etc. For what value I can give? Instead of 0, for what value I can deduce that series? Tell me. Our function is x square defined in the interval minus pi to pi. Tell me.
Sir, x ന് പൈ എടുക്കാവോ?
X ന് pi കൊടുക്കാം. So if I put x equal to pi, what will we will get? X equal to pi. So pi is an endpoint, right? Endpoint. Pi is an endpoint. So what is the convergence theorem says? If I put for this, if I put x equal to pi, and pi is an endpoint, then the convergence theorem tells us endpoint ആണെങ്കിൽ f of pi I will take what is the endpoint. So convergence theorem tells us, yes, if it is endpoint, that means our x is c plus 2l, right? So pi is 0 plus sorry, c is minus l plus, so this is x equal to pi. If x equal to pi, then we have f of pi uh, minus pi plus c here. Okay, so that means we will take this, if it is a n at the end point, we will take left hand limit and right hand limit of the end point and take the average. So we will get pi minus 1 by 2 times f of pi minus plus f of minus pi plus is equal to, so this is very important because if it is a point at the end point, then you can write this as pi square by 3 minus 4 times cos pi by 1 square minus cos 2 pi by 2 square plus cos 3 pi by 3 square, etc. Okay, so you will get what is f of x? F of x is x square, right? Then what is f of 1 by 2 times f of minus pi? F of pi minus, that means the left hand limit. This is pi square. So you can write pi square plus, what is f of minus pi plus, what is minus pi plus? It's continuous at that point. So this is also equal to pi square. So this is pi square is equal to pi square by 3 minus 4 times minus 1 by 1 square minus 1 by 2 square minus 1 by 3 square minus etc. So this implies pi square is equal to 2 pi square by 2, that is pi square by 3 plus, you can take minus outside, plus 4 times 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus etc. So it implies pi square minus pi square by 3 is equal to 4 times 1 by 1 square plus 1 by 2 square plus etc. So which implies 3 pi square minus pi square, 2 pi square divided by 3, which is equal to 4 into 1 by 1 square plus 1 by 2 square plus etc. So from here you will get by 2 pi square by 12, that is pi square by 6 is equal to 1 by 1 square plus 1 by 2 square plus etc. So we derive this. So anybody have any doubt here? So the important thing is in order to use convergence theorem, you have to first check whether this point is endpoint or not. If it is not an endpoint, you can directly put that value. Here this is not an endpoint, right? X equal to 0 is not an endpoint, so we can directly write f of 0. Otherwise, what we want to use, if it is an endpoint, x equal to pi is an endpoint, therefore I will take f of 1 by 2 times left hand limit f of minus plus f of minus pi plus. Okay, so that means my f of x is equal to x square defined on the interval minus pi less than x less than or equal to pi. So it's the end point. I will take the right hand limit of this, sorry, left hand limit of this and plus right hand limit of this. But in this case it is continuous, therefore we will get the same value. Okay, some for few functions it may not be continuous, then we will get different values. Okay, I will do such problems in the next class. So this is you work out this problem, 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc is equal to pi square by 8. Okay, so anybody have any doubt?